All right, so I have some information. This was a data file that was given to you on this golf course on hole 12, and I guess each golfer's score. And so what I want to do is construct a discrete probability distribution. How do I know it's discrete? Because however many times it took them to get the ball in the hole. See, I know all about that golf stuff, right? These are countable values, so it's not like it can be 7.5 or 7.3. And so the first thing I want to do to construct my probability distribution is I need my random variable values. So I don't really know just by looking at this where they start. So probably what I would do right away is just sort them. So I can see they start at 3. And if I go to the end, they end at 8. So in other words, 3, 4, 5, 6, 7, 8. So these are the values that my random variable would take on. Now from here, I want to find the frequency, which remember frequencies are just counts. And so I'd count 1, 2, 3, 4, and then I count 1, 2, the 4s, 1, 2, 3. Yeah, that's too much for me to count. So probably what I would do, the easiest thing and quickest, is go to Insert, go to add a pivot chart, pivot table, however you want to do it. Select your table. So in other words, that's going to be all of my data that went to what, 444, I think it was. Yeah, there we go. And now I want to output this, probably right there is good enough. So I say okay, and I get this stuff here. So I can see that I want the holes, but I don't want to sum, I want to count. So I would click the value field settings and change it to a count. And then I would break these up in categories. Okay, so I don't need that right there, but I need I guess I could have left that, but this is all I need. So these numbers here are my frequency numbers, 139, 27, and 4. If you don't believe the sum, you could go ahead and sum these, but we already saw it went to 444. And then of course, this was what made it, it's 443 values, but then this made it 444. All right, so now from here, what I will do is I will find the probabilities. So how do you find a probability? Well, you take, and let me go ahead and put that I'm going to do that here. So this is going to be my probability. You take, sorry, there's my dog. You take the frequency divided by the total. I want the frequency to change for each row, but I don't want the total to change. So I'm going to absolute value that. I hit F4 on my keyboard. I know you guys would max at something like function F4, but basically what it is you're just putting dollar signs. So when it copies, it absolute values that value. It's getting loud, Scotty. All right, and so somewhere here it said round your answers to 4 decimal places. So I think that would be 4. And now I can copy this straight down. A good habit to get, copy that sum to make sure this column sums to 1, because all probabilities should sum to 1, right? All right, now it says here, based off of this table data, okay, what is the probability of a player scoring less than or equal to a par? And this is par, somebody says here 4. So what is the probability that it would be 4 or less? Well, all you'd have to do, so the probability less than 4, so X is scoring less than or equal to 4, would be based on they scored 4 or less than 4, which would be 3. So that would be my answer. Then next it asks, what is the expected score? Now this takes a little bit more, okay, because expected value, what you have to do is you have to take each, and this is my probability, you have to take each X value and multiply it times its probability. Okay, so each x value times its probability. So once again, I would drag that formula down. I already know this is a sum formula, so I can see that's my answer. So this would be expected value. So my expected value would be the 5.3160 well, I guess I'll round to 4 decimal places like they say to do. And it took my 0 away. All right. What is the variance? Now this one takes a little bit more that you have to do. So basically what I'm going to do is I'm going to take each x value and subtract it from the expected value that I just got and square it times its probability. So that's a lot, right? I'm going to take each x value minus the expected value. This is what I would expect somebody to score on this whole. And I'm going to square that and multiply it by the probability. So the only thing that's going to stay the same is the expected value. So looking at the formula, I take the x value minus the expected that I don't want to change. I square that times this actual probability. Okay, my actual probability. I take that, I drag it straight down. I copy this straight across to sum it, and this value, 0.7037, is the variance. So that's the formula for the variance that you'll see on the formula sheet. The standard deviation is a lot easier because once you find the variance, you just take the square root of the standard deviation. And once again, it said to round to 4 decimal places. So there's 4 decimal places. So this is how to take data, put it into a probability distribution where then you can actually answer questions, right, based off of the data. What would you expect to get? The spread, the variance being the spread, and remember that's still square units, and then the standard deviation. So, you know, there's almost one, okay, that there's almost a spread of one more time to get the ball in the hole. And that's it.